Hello and welcome back to Functions. First, I want to thank all the nice people that support this channel by liking and subscribing. In today's part 2, we're going to deep dive into quadratic functions, one of the most essential topics in this series. At this level, you should know that there are three formats of quadratic functions. The first one is the standard form, the one that everybody knows. It's simply y equals to ax squared plus bx and plus c. The second one is a very crucial one. It's called the vertex form, and it's given by y equals to a times x minus h squared and plus k. In this case, h and k form the coordinates of the vertex of our parabola. And the third one is the intercept form, the more comfortable one, which is given by y equals to a times x minus p times x minus q. Now, in this case, p and q are the zeros or x-intercepts of our parabola. We first begin by understanding the basic uses of all of these letters, a, b, c, h, k, and so on. In the standard form, a, otherwise known as the leading coefficient, is responsible for the vertex stretch slash compression. So let's say that the x squared function looks as so, the standard one without any stretching or compressing or shifting anywhere. Now, the greater the value of the leading coefficient, the thinner the parabola is going to be, and vice versa. So for example, if your a were supposed to say 3, then you would have 3x squared. The parabola would look something like this. However, on the other hand, if you had a smaller value of a, let's say 1 over 5, x squared, then the parabola is going to be wider. Now the a also has another responsibility. If your a is positive, in other words, greater than 0, then our parabola is going to be looking up. A more professional way to say this is concave up. However, if the value of a is less than 0, or in other words, negative, then the parabola is going to be concave down. So, always pay close attention to the sign of the a, especially when you're graphing the parabola by hand. Up next, we have the value of b. Now b can be used to do two things, or actually it does two things at the same time. Using the value of b, we can find the axis of symmetry, since all parabolas are always symmetric, and at the same time, we can use that b to find the x value of the x-coordinate of the vertex. Now, the golden formula for finding this axis symmetry, or the x value of our vertex, is going to be x is equal to negative b divided by 2a. Extremely important, so please remember this formula. Just as a quick example, let's say we have a quadratic function like this, and we're tasked with finding the axis of symmetry and the x value of the vertex. We would use the formula and say that x is equal to negative b. In this case, b is already negative, so it's going to turn positive, positive 5, and then we use it to divide by 2a. Now the value of a here is 4, so times 2 is 8. And here, this value of x is the axis of symmetry and also at the same time the x value of our vertex. And finally, we have the letter c, which is simply responsible for any vertical shifts. So that means if c is greater than 0, then the parabola is going to move upwards, the entire parabola, or if c is negative, then it's going to move downwards. Next up, let's discuss the vertex form in a bit more detail. The vertex form is extremely comfortable to use to identify any transformations of the parabola, because here The value of A, just like before, takes care of any stretching and compressing. However, the values of h and k are what helps us easily identify the movements sideways, upwards, or downwards. Changing the value of h, meaning that the x-coordinate of our vertex is going to change. So that means that will shift the entire parabola. And of course, k is used once again for the vertical translations, whether it's upwards or downwards. We can arrive at the vertex form of any quadratic function using a method called completing the square. You may have heard of it before or even done it. However, just as a refresher, I will show you an example. First of all, when doing the completing the square, the leading coefficient of x squared must be 1. So that means the first step that we have to take is to factorize 3 outside of the parentheses. Next up, the idea inside of the parentheses is to add b divided by 2 squared and then also subtract it. So the idea is I add and subtract the same thing. So in reality, I added 0. However, you may ask, what's the point then? Well, the point is by adding b over 2 squared, I can turn it into the vertex form, and I will show you just how. So now, after the 2x, I add b over 2 squared. Our b in this case is the number 2. I divided by 2 is 1, and then I squared, it is still 1. So now I have to subtract that 1, and don't forget the minus 5. Now, we're gonna segment this. We're gonna take a look at this here. It might remind you of this thing, a squared plus 2ab plus b squared. The only thing missing is the squared above the 1, however, we never write that. Now, what does this green formula simplify to? Simply a plus b squared. This you have definitely learned. So, technically what happens here is inside of the parentheses, I can write this green expression in the green parentheses as x plus 1 squared. And then in the end, I have minus 1 and minus 5, which I can put together is simply minus 6. Finally, I can open the parentheses. So now I get 3 times x plus 1 squared and minus 3 times 6, which is negative 18. And here we have arrived at the same format as the vertex form. So that means the value of our h in this example is going to be negative 1, because in the vertex form it's x minus h, and the value of k here is going to be negative 18, because in the vertex form it is originally plus k. Lastly, for the intercept form, there are two ways to get it. Either we can take the quadratic function, solve it by equating to 0, and then plugging those zeros instead of p and q, which takes up quite a lot of the time, and perhaps some would consider it doing the work twice, or we can simply use factorization. So let's take a look at a quick example, which I'm going to give by 4x squared plus 15x and plus 9. The idea is this. First, I have to find the value of b. In that case, it's 15. And then I have to find the value of a times c. So 4 times 9, 36. Next up, my goal is to split this 15 into two numbers. Let's just call them m, and I'm going to call the other one k. However, m and k can't just be any numbers. They have to fulfill two conditions, which I've written here. These two conditions will be the following. M plus k has to equal b. So in our case, has to equal 15. And then their product has to equal ac. So 36. Please do keep in mind that both m and k can actually be positive or negative numbers. However, in our case, they're both probably going to be positive. I do have to apologize. This here must be a 12. Well, in that case, both m and k are going to be equal to 6. They can be the same number technically. So what happens here is now I can rewrite our quadratic function as following. 4x squared plus 6x, and then plus another 6x, and add 9. Then I can group them into pairs. This is one pair, and this is another, and I factor them separately. From the blue pair, I can take out a 2x, and then in the parentheses, I'm going to get 2x plus 3. In the other pair, I can also take out a 3, and what I have left in the parentheses is 2x plus 3. And finally, we can rewrite them as the multiplication of two linear factors, 2x plus 3 times 2x plus 3. A more simplified way to write this would be as a squared. Here is another example. We have to factorize this quadratic function. So b is equal to 7, and ac this time is going to equal to negative 60. We have to split the 7 into two numbers. However, we already know that one of them is definitely going to be negative because of the ac value. So a good idea could probably be 12 and negative 5. When you add them together, we get 7, which is perfect, and when we multiply them, we're going to get negative 60. So that means it probably will work. What happens now is that I rewrite this quadratic function as 3x squared plus 12x, then minus 5x, and minus 20. And then I put them into pairs and just factorize them. The factorized form should be 3x plus 4 plus 5 and times x minus 4. And this here would be the factorized form. And when we equate this to 0, we can easily identify the zeros, because all you have to do is take any linear factor equated to 0 and solve for x, and you will have two x values. Lastly, we do have to speak a little bit about the domain and range. The domain for any quadratic function is always going to be x belongs to all real numbers. On the other hand, the range is going to be a little bit more different, and it's going to depend on two things: the y value of the vertex and the concavity. Let's just imagine for a second that we here have a parabola that's concave up. So that means the vertex is about somewhere here. And let's just say the coordinates of this vertex is going to be 5 and 3. So if the parabola starts from 5 and 3, expands into both sides and upwards forever, that means the range here is going to begin from 3 and go all the way until positive infinity. However, now let's imagine we have a concave down parabola with the vertex negative 3 and negative 2. So now that means that the y values is going to start from that negative 2 and go all the way until negative infinity. So in order to determine the range, you're always going to have to identify the concavity and find the y value of our vertex. So that's it for today. In the next video, we will speak about rational functions. So I really hope to see you there and have a nice day. Bye.